Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and discuss a very important topic on how to call Fortran libraries directly in Java using the JNI. And Fortran is a language that was developed specifically for scientific computing, and just like C++ or C, Fortran also directly compiles to the native code, the binary code or machine code or object files. So running or calling basically Fortran functions and executing them is very fast, right? And obviously just like C++, Fortran compiled Fortran files are platform dependent because they directly compile to the native code. Now, Fortran was written was mainly used for scientific computing, and if you are looking for a particular scientific function, you will most likely find it in Fortran language. For example, if I go to my browser, there is this website called netlib.org, and netlib is basically a collection of mathematical software, papers and databases. And there is this search option here. Let's say I want to search for see if they have a file or something in their library that can calculate array function for me. And if I look at the files, almost all of these have the basically the extension of .f. And .f identifies Fortran files, a file that is written in Fortran language. So this is array AI, this is the derivative of the array function. So these are all Fortran, right? So if I just basically open it with a text editor, as you can see, this is a function written in Fortran. And it's just and I can easily download it. And if I know how to use JNI to bind this Fortran library to my Java, I can easily call it, okay? Now obviously another example is SciPy. If you go to scipy.special, all the special functions, most of them that are here are basically a direct translation of the Fortran. They directly calling the underlying Fortran libraries. For example, if I click on the array function here, as you can see, the reference is just the mathematical library, the netlib, and basically it has the array function and many other functions. Okay, so basically SciPy is just using the basically most of the special functions and most of the routines and or subroutines in SciPy are basically based on the Fortran libraries. And if I go to GitHub, the main repository for the SciPy, and go to the actual SciPy source, go to the SciPy and go to the special, which includes all the special functions that are listed here, and spec_func, there is one Fortran file, and if I open it, it's a huge Fortran file. I believe it's about 12,000 lines of code. And this has basically the implementation, the Fortran implementation of all the functions. And wouldn't it be nice if I could just download this Fortran file and directly bind this to my Java project and be able to directly call all these functions in Java? So that's what we're going to talk about. So if I go back here to SciPy, let's go back to our PowerPoint. So C++ and Fortran have nice interoperability, which means I can include a Fortran file in the C++ and combine both my CPP files and Fortran files into object files, which is nothing but the binaries that the CPU understands. And then the linker can link all the binaries together into one file. It could be a dynamic library, a static library, or executable. Okay, so once the C++ and Fortran are compiled to the machine code, then we can bind them together. There is no difference between an object file that is created from C++ or an object file that is created from Fortran. We just link them together. All right. Now, for Fortran, we don't have a concept of header file, right? We just have one .f file, which is the source file, the implementation. So how do we address them? Exactly the way we address or call a function from another CPP file. We have to prototype them with the basically external keyword, saying that this is an external symbol, and we have to also prototype them by pass of reference or pass by pointer, which means if we know the signature of the function, the arguments, we have to prototype it by reference or pointer. We cannot pass a constant literal, a number, right? We cannot say double. It should be a double pointer or double reference. So how do we set up Fortran in our Eclipse IDE? So there's this Fortran plugin for Eclipse, and you need to install that. But before that, you should also install a Fortran compiler, a Fortran compiler on your operating system. So if you are using a Mac OS, you can go to this GitHub repository, github.com fxcoudert/gfortran for Mac OS, and it has the Fortran Fortran compiler for basically all the Mac OS versions. So you download it as a package file on your Mac OS and then install it. So if you're using Windows or Linux, you can just Google search Google for a Fortran compiler for your operating system. So after that, you install the Fortran compiler, and then you can install this Fortran plugin if you want to actually create. This allows you to basically create a Fortran project. It adds a Fortran perspective. And then you create your C++ project, and then create your CPP file, write your code. Also, you add your Fortran source files. So for Fortran, we only have a source file. There is no concept of a header file. So we just have this Fortran source file, and you add them to your source folder of your C++ project. And then if you just build the C++ project, the tool chain only includes the G++, so C++ compiler and the C++ linker. But basically we need to compile the Fortran source files before compiling and linking CPP files, the C++ files, right? So we want to first compile the Fortran files in our project and compile them to an object file binary. So you have to add the Fortran compiler to your tool chain in basically your C++ project. And after that, when you run the build on your C++ project, first the G compiler, the Fortran compiler is run, and it compiles all the Fortran files, source files, to the object file binary. And then the G++ is run, it compiles all the C++ source codes to binary. And then the GNU linker, the G++ linker, again, linker doesn't matter if it's a Fortran linker or a C++ linker, because it just links symbols together. The job of a linker is just symbolically links the object files together to create one executable or one library. So after compiling the Fortran files and then the CPP files, then the G++ linker is run, and it can link all the object files together, and we can successfully call these Fortran functions in our C++. But then in order to prototype them, because when we want to call a function in C++, we have to tell the compiler that this function exists. So we have to give compiler some sort of prototype of the function. We have to use extern C to say that it's compatible with C, and then the name of the function, typically in lowercase letters or uppercase, it's compiler dependent, and with the underscore after the name of the function. So we have to add this underscore directly after the function, the name of the function. And even if the Fortran function doesn't have this actual underscore, we have to add it when we prototype the Fortran function in our C++ file. Okay, so we have to do this, and then when we compile the C++ file, the C++ linker takes care of linking. Okay, so because we already compiled the Fortran file to C++, basically to object file, to binary files, and then the linker can grab all the object files, all the binaries, and resolve all the symbols, and then create one executable or one dynamic library. So again, with the tool chain that we need, it's not just the G++. We have to also have a Fortran compiler in our tool chain. And the Fortran compiler will automatically compile all the Fortran files before the C++ compiler is run, right? And this is how we interact between C++ and Fortran. We add the Fortran compiler to our toolchain. So if I, for example, run a terminal in my Mac OS and say G++ -- version, it tells me that the G++ has been installed, and I can also check if the Fortran compiler is installed. So I install G Fortran -- version, and as you can see, I have the GNU Fortran. Okay, so I have successfully installed both a C++ compiler and a Fortran compiler, and I downloaded it from this GitHub repository, the Fortran compiler. And now in Eclipse, what we do, we download and install this Fortran plugin for Eclipse, and then basically you go to the install new software, and then you select your basically release repository. Let's say my Eclipse is Neon, so I select the release repository for my Eclipse, and here in this filter you search for Fortran, and then in the programming languages select these Fortran development tools and Linux, Intel, Fortran compiler support, or if you are on Intel platform, and then click on next, and then you install the plugin and then restart your IDE, and you end up with installing this Fortran perspective. Okay, so let's head to Eclipse and look how we can actually use some Fortran functions and add them to our C++ project, and then create for example an executable or a dynamic library or a static library. So here in my Eclipse, I have also now have this Fortran perspective. Previously I had Java and C++. Now I also have this Fortran perspective. And then what I'm going to do, I'm going to go select one of my working sets. Let's call it tests. And then here I'm going to create a new C++ project. Let's call it test Fortran. And then I'm going to say it's a hello world C++ template, and then let's have both debug and release and finish. So this is my C++ project, and it's right now it's not in my working set, so I can click on this arrow and then go to my edit active working set and then add this test Fortran to my working set. Alright, so this is my working project, and now I can build it with C++, with G++, right? And if I built it in a debug mode. If I go to debug folder and look at the source file, I have this testfortran.o. This is the object file, right? This is the binary, the result of the compilation of the source file, right? This is the binary. And then if I click on run, and I get the hello world. All right, now let's say I want to add a Fortran source file, and let's say I went to SciPy and then downloaded this, and let's say I want to use one of the Fortran functions that are in SciPy. So back to Eclipse. So I have already downloaded SciPy Git repository. And if I go to the SciPy folder here in the special functions, there is this folder called AMOS. This is for some of the complex functions, calculations, Bessel and Airy for complex numbers. But there is, for example, this ZABS, and this ZABS is a simple function, is a Fortran function that takes a complex number, the real part and imaginary part of a complex number, and just returns its magnitude, a square root of the real part squared plus imaginary part squared, right? This is the modulus of a complex number. So I want to call this include this in my C++ project. So I copied it and pasted it in my source. And if I double click it, I can open it, right? Because my Fortran plugin allows me to open it, and you see these lines, and these lines are important. Your source code should be between these lines. So writing Fortran programs is outside the scope of this tutorial, but at least we can open it and look at it. So the name of the function is AZABS. It takes two double parameters and returns a double precision result. And ZI and ZR, these two parameters are also double precision values. These are double values. All right, so how do I actually include this or call this function? So what I need to do, first of all, if I build this now and look at my source and the binaries, I couldn't actually compile this Fortran. Right now, the toolchain, the C++ toolchain only compile this CPP file, not this Fortran file. So I want to be able to first compile this Fortran file and create the actual binaries that my CPU understands. So in order to do that, I right click on my C++ project, click on properties, and this is the important part. So we have the C++ build, and there is this toolchain editor, and you see here it's only the C++ toolchain, C compiler or C++ compiler, and then the C++ linker or C linker. But I want to also add the Fortran or any Fortran compiler to my toolchain. So I select toolchain, and here I have this GNU Fortran compiler. This is the Fortran that I have installed and added to my toolchain. All right, okay, apply, and now okay. Now notice what happens now if I hit the build. Now, as you can see, I was able to also compile this Fortran file and get the object file, the binary file. All right, so this means that now I have the binaries, the object files, both from the CPP and the Fortran. And again, once I have the binary, it doesn't matter if it came from Fortran or the C or CPP. It's just binaries, and one linker, the C++ linker, can link these together. So what do I want to do here? I want to be able to call this function and use this function in my C project. And if I can do that, then I can use JNI to use that function directly from C, and the C function, the C code calls or uses that Fortran function. So obviously I don't have a header file for this function. Again, instead I tell the linker that I'm going to use an external symbol. This function is an external symbol, so go search it into another object file. It's not inside this object file. Remember, each object file, each compilation file or a source file, it could be a .f file or .cpp or .c, it turns into an object file, a binary file, right? .o. And then it's the job of the linker to resolve all the symbols that are inside these binary files. And then we have to basically, if there is no header file, there is no prototype, we have to externalize or basically tell the linker that it's an external symbol. Tell the linker it's an external symbol, and then the linker goes and looks into the other object files in my project to see if we can find that symbol. Extern C, and what is the name of this function? AZABS. And I mentioned that we have to add this underscore, and then the parameter, the prototype, and the return type is the double, because it's a double precision. And then the parameter type is also double. It takes two parameters and both are double precision. So double. And as I mentioned, we cannot use double here because we cannot pass literals, double literals to these external calls to the Fortran function. So we have to pass either by pointer or by reference. Either this, or we do something like by reference, something like this. We're going to try both of them. So let's try first the pointer type. So what I'm going to do, I'm going to define two variables. Double x is 3 and y is basically 4, and these are going to real part and imaginary part of a x plus JY. This is a complex file, and I know that the ABS of this is a square root of x squared plus y squared. So 3 squared plus 4 squared square root. So the ABS should be 5. All right. And then I'm going to define this z variable and say a z abs underscore, and then address pointer of x, or address of x, and address of y. And then I'm going to do a cout. Basically the magnitude of z is equal to z, and then end line. Okay, so let's see what happens. So I have the binaries for my C++ and Fortran. All I have to do, I have to tell the linker that search this symbol, this function, outside the binary or object file of this CPP file, outside this binary. So this symbol is external to this object file. So go find this symbol in other object files in this project. So if I build this, I get a linker error, and it tells me that it couldn't find this symbol. So I mean, again, this is the compiler dependent, but on my machine I have to use the lowercase azabs, and I have to also add this underscore after the name of the function. So if I build this again, everything works fine, and the linker was able to find this symbol, and if I run this, I should get 5. Yes. So what I'm doing right now, I'm calling a Fortran function in a C++. If I can do that, then I can just use JNI to call this, because now I can use this as a regular C++ function. So now we can use JNI. Now we can use JNI to call this in Java. All right. So if we can bring a Fortran function to C++, we can actually bring it to Java as well, and that's the trick. Now instead of passing by pointer, if I pass by reference and build this again, then basically what happens here, I don't need to pass the address of these variables. I can directly pass the variables, right? Because this is passed by reference, and it's still complaining. Okay, so this one should be underscore. So on my computer, I have to use underscore for the name of the function, small letters, not capital letters. All right. So Fortran is case insensitive, so you can use capital letters or small letters, but C or C++ is case sensitive. So on my machine, I have to use small letters, AZABS, and add this underscore. So if I build this again, it works fine. The linker has no problem resolving this symbol. If I run this, I get 5. So it's up to you to whether use pass by pointer or pass by reference, but you cannot do, for example, this. Let's see if this works. This works. Let's see. It doesn't work because we didn't get 5, right? Now it cannot actually call this function. It doesn't throw an error or an exception, but we cannot actually use it. Even if I put 3 and 4 here and then build it, the build is fine. But if I run this, I don't get 5. I don't get the result. This function doesn't do anything. So I have to either use pass by reference or pass by pointer. So one more time. So X and Y. And if I run this, I get 5. All right. So take this in mind that you have to prototype them using the extern C, and then either the capital letter or small letters for the function. You have to add this underscore after the name of the function, and the parameter types cannot be literals. We cannot have double or float here. It should either be passed by pointer or passed by reference. And I hope you enjoyed this lecture. Again, the takeaway here is that we can directly add a Fortran file to our C++ project. And then in order to call the functions, first we have to compile this Fortran file to the binary, to object file, so that the linker can link it to our binaries from C++ source. All right. After we do that, so the way we do that, we install a Fortran compiler, and in the tool chain of our project, we add it to our tool chain of the project. So we go to the build option here, C++ build, and then the tool chain, and we added the Fortran compiler. And the Fortran files are compiled before the CPP files, and in order to see that, we can go to the sources.make file, and as you can see, all these Fortran files are compiled before the C++ files. All right, so we have these Fortran files, Fortran sources, and then we have the C++ sources. And then we don't have any header files, but we have to prototype the Fortran functions somehow for the C or C++ compiler. So we have to externalize them and telling the linker, hey, go find this symbol, which is a function, in some object file, binary file that is not in this that is not inside the object file that comes from this source file. So the linker went into and looked into the other object file that we have and was able to resolve them. Again, on my machine, I have to use small letters for the function name, and I have to also add this underscore. And we should always either use pass by pointer and pass by reference. We cannot use basically raw primitives. Okay, so I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.